isn't a cuboid. It could be a triangular prism like this one here. For this question, we're going to work out the size of the angle between EC and the plane ABCD. So first of all, let's draw on the line EC, which is this line here. And what does it mean by the plane ABCD? Well, a plane is simply a flat surface, so we need to find the flat surface that connects A, B, C, and D. That's just the base of the triangular prism here. But it's still not immediately clear from our diagram which angle we're trying to find. If you're ever trying to find the angle between a line and a plane, you'll notice that one of the points will be on the plane and one of them isn't. You can see that C is on the plane, but E is above the plane. What you want to do is drop a vertical line down from E until you hit the plane, so that would be down here, and then connect up the 2 points that are on the plane, so A and C, across here. You can now see that the angle between the line EC and the plane is this angle in here, so let's label that one X. The type of wording used in this question is common for Edexcel, but not AQA. If it were an AQA question, it would probably just say work out the size of angle ACE. So now let's go and solve this question. If I look at the triangle ACE, I don't actually have any of the information for this triangle at all, so I'm going to need to work out at least 2 bits before I can return to it to find X. First of all, I'm going to look at the triangle that's on the front of the prism here. This will allow me to find the length from A to E. So let's look at the triangle ADE. We know the angle is 20 degrees. We also know the length from E to D because that's the same as the length from F to C, so that must be 14 centimeters. We can now use trigonometry to find A to E. So let's label on, AE will be the opposite, and ED is the hypotenuse, and we don't need AD, that's the adjacent. So for this one we use the opposite and the hypotenuse, so we need to use sine. So we could say sine of the angle, so sine of 20, is equal to the opposite, which we don't know, so we'll just label that as EA, and divide this by the hypotenuse, which we do know, that's 14. If we multiply both sides by 14, we find that EA is equal to 14 sine 20, which if you type into your calculator gives you this number here. So now we found the length from E to A, we can add this information to the red triangle. So EA is 4.78 and so on. Now in order to find X, we still need more information from this triangle. We're going to try and find the length from E to C next. To do this, we're going to use the triangle from E to F to C. This is on the top face of the prism. So if we draw out this triangle, it looks like this. We know the length from F to C is 14, and we actually know the length from E to F, that's the same as from D to C, so that's 10. We can use Pythagoras to find the length from E to C. So if we do EC squared is 10 squared plus 14 squared. If you use your calculator for this, you'll find that EC squared is equal to 296. And then to get EC, we just square root both sides, so EC will be the square root of 296. Now you could square root this and turn it into a decimal, but since I know I'm going to need this length in a moment, I'm going to leave it in that surd form as square root 296. So if I go back over to my red triangle now, I can label from E to C as square root 296. Now we're ready to use this triangle to go ahead and find X. So for this one it's trigonometry, we label the opposite over here EA, and we can label the hypotenuse, that's square root 296, and for this one we need to use sine. So sine of X is the opposite, so this 4.78 and so on number, divide by the square root of 296. Now you need to be really careful when you type that right hand side into the calculator. You cannot just type 4.78, that would be another example of premature rounding. Since this isn't the answer to the question yet, we can't round, so you need to make sure that you get that 4.78 back up on your calculator with all of the decimals after it. So we got the 4.78 and so on by doing 14 sine 20. So do 14 sine 20, and that number will be on your screen, divide that by the square root of 296, and you get this number here. If you did just use 4.78, then you may get a slightly different answer to the real answer. So now we can use inverse sine to find the answer to this angle. We do x equals inverse sine of this number here, which gives us the answer 16.2 when rounded to 1 decimal place. Another shape that you sometimes see in exam questions is a square-based pyramid. We may get a question that says ABCDE is a square-based pyramid, and we might be asked to work out the volume of the pyramid. To find the volume of a pyramid, you use the formula 1/3 times the base area times the perpendicular height. Now at the moment we don't know the perpendicular height, and we also don't know the base area, so we're going to need to go and find those first and then return to this formula later. Let's start by trying to find the perpendicular height, which would be from M to E. To do that, we need to use this triangle here. So if we take a closer look at this triangle, we want to find the length from M to E. This will be using trigonometry. So if we label up this triangle, the one opposite the 72, that's the opposite. The one opposite the right angle is the hypotenuse, and the other side is the adjacent. The perpendicular height is from M to E. That's the opposite, and we have the hypotenuse, so we're going to use sine. So sine of 72 will equal the opposite, which we don't know, so we can just call that ME, over the hypotenuse, which is 15. To get ME then, you multiply both sides by 15, so ME is 15 sine 72, which is this number here. Now it will also be helpful in this question to work out the length from M to C. Since MC is the adjacent and we know the hypotenuse, we can use cos. So cos of 72 is equal to the adjacent, so MC, divide by the hypotenuse, which is 15. If you multiply both sides by 15, you find that MC is equal to 15 cos 72, which is this number here. So if we add both of these lengths onto our diagram, we've got the height now of ME, which is 14.2, and so on, and we've also got MC, which is 4.6, and so on. So we've now got the perpendicular height, but we need the base area. We're going to look at this triangle here that's on the base of the pyramid. So if we draw out this triangle, ADC, so we don't know any of the lengths of this triangle at the moment, but we do know there's a point M right in the middle of the line AC, and to get from M to C is 4.6, and so on. Now since M is the midpoint of the line AC, the length from A to M must be the same as the length from M to C. So from A to M is also 4.6, and so on. So if we wanted to find the length from A all the way to C, we would just double this number. Now remember, we're not doubling 4.6 here, we're doubling that whole number, 4.6, and so on, with all of the remaining digits. So if you get that number back on your calculator screen and double it, you'll end up with 9.27, and so on. Now this is where things get a little bit tricky. We want to find the length of AD and DC, and it doesn't look like we have enough information to find them since we only have one of the sides, but it is possible. This pyramid is a square-based pyramid. This means the length from A to D must be the same as the length from D to C, since the base of the pyramid is a square. So whatever AD is, let's call it X, that's the same as DC, so that's also X. So this means the hypotenuse squared, so 9.27 and so on squared, will be the same as the sum of the squares of the other two sides, so x squared add x squared. If we leave the left-hand side alone, but then add x squared and x squared, we get 2x squared. If you do square the 9.27 and so on, and then divide it by 2, you'll end up with this number here, and if you divide the right-hand side by 2, you get x squared. To get x, we can then just square root both sides, so x will be the square root of this number, which gives you this number here. So we've now found the lengths of the square on the base. So from A to D is 6.5 and so on, and so is D to C. We're now ready to finally find the volume of the pyramid. Let's go back to that formula. The volume is 1/3 times the base area times the perpendicular height. So we need to do 1/3 multiplied by the area of the base. To find the area of the square, you just multiply its length and its height. So 6.5 and so on times 6.5 and so on. And then we multiply this by the perpendicular height, which we found earlier, that's from M to E, 14.2 and so on. Once again, I cannot stress how important it is that you don't use rounded numbers here. You cannot type 6.5 times 6.5 times 14.2, you need to use the full number that was originally on your calculator screen. So if you do that properly, using that whole number, you'll end up with this number here. And since this is the answer to the question, we are able to round. This one hasn't actually given us an accuracy, so let's say it was to one decimal place, 204.3 centimeters cubed.